Hi everyone, I hope you've been practicing your mechanisms for acetal formation. In this video I want to look at the mechanism for imine formation, which has similar steps, but there are very important differences between this mechanism and the mechanism for acetal formation. Just like acetal formation, we are reacting a carbonyl, either an aldehyde or ketone, with something that attacks it. For the acetal, it was an alcohol. For imine, it will be a primary amine. Another similarity that confuses students is that it is run under acidic conditions, but we do not protonate in the first step, unlike the acetal formation mechanism. Here are a couple of notes that you want to keep in mind as you go through the mechanism for imine formation. We have enough acid to protonate an alkoxide that we're going to encounter in the mechanism, but we do not have so much acid that we protonate all of the amine. Amines are more basic than alcohols, so there is a danger of protonating all of the amines, and if you do that, you will not have any unprotonated amine to attack the carbonyl group. So again, just to emphasize, do not protonate the carbonyl group in the first step. You will attack right away. It is less steps than the acetal formation. It's 6 steps instead of 7. Remember how we had 3 steps to the hemiacetal for acetal formation? Here we have 3 steps to the hemiaminal. Okay, it's very analogous to the hemiacetal, and then only 3 more steps after that to the imine. A reminder that imine is a molecule that has a carbon-nitrogen double bond. We need this to be a primary amine because to get the double bond in this position we need to lose 2 hydrogens. As always, when you start a mechanism, redraw your starting materials that are being used in the first step. Do not draw mechanisms off of your professor's drawings. And there's no protonation in the first step. We will have direct attack of the amine to the dot, the carbonyl group. So we will form an O-. We do have this amine attached, but it still has its 2 hydrogens. And don't forget our methyl group right there. Now we need the trace amount of acid, or your professor may just indicate this with a pH of 5, pH of 6, and we are going to protonate first the alkoxide. I have here HCl. We could use that. Oops. We didn't create HCl, so I'm not going to put a plus. I'm going to put the HCl over the arrow. All of this is reversible as well, just like we saw with acetal formation. That nitrogen is still protonated and positive. We did create Cl-, which is good because we're going to use that to deprotonate the amine. That is called the hemiaminal. We did create HCl. Let me draw that before I forget it. And we did create it in the previous step. So let's not put it over the arrow. Let's just have it plus. We'll put the arrow next door. This is a hemiaminal. and it took us 3 steps to get to it. Right, it's an amine with a hydroxy group. Very analogous to the hemiacetal. We have 3 more steps to the final product. Just like with the acetal formation, you want to get rid of this OH, but it's not a good leaving group. We're going to protonate it to make it a good leaving group. Just like with the hemiacetal, when we protonate the OH, it's ready to leave, but we don't make it leave by having an attack of another atom. We make it leave by making a double bond, just like that. Okay, look what we get. We get this carbonyl group, still has the methyl here. We made a double bond to the nitrogen. That nitrogen still has the hydrogen, and I'll write it to the left. And that nitrogen still has the isopropyl group. And that's it. We kicked out water. Why don't I put water here? OH2 or H2O. Because we're going to use it to deprotonate this nitrogen to get it to be the neutral imine. That's it. It only took us another 3 steps from the hemiaminal to get to our product. There is our product. We did create a molecule of H3O plus. I did draw the isopropyl group to the less crowded side of the double bond. Pick a side, either left or right. I normally wouldn't care if you draw it to the left, but I do care that you make an angle. Don't draw the R group straight up. Let me label the steps, or at least number the steps. 1, 2, 3 to the hemiaminal, 4, 5, 6 to the final product. In the acetal formation, we had a special name after this step when we made the double bond to an oxygen. That was called the oxonium ion. We don't have that special name here, but we do have this imine that's protonated. So you do go through the protonated imine. All the steps here are reversible, and you could shift the equilibrium back to the starting material by doing a hydrolysis, by adding water. Because we did kick out water, go in the forward direction. To go in the backwards direction, you add a lot of water and some acid, and it will replenish or replace that oxygen, getting back to the starting material.